This is our second program, and we are going to talk about date types, including input and output. There are two date types, built-in date type and user-defined date type, which is also known as abstract date type. In the early days, C++ is viewed as an extension of C, hence it's no surprise to see the basic built-in types are almost identical for C and C++. The most commonly used built-in date types are int for integer, float and double for decimal values with different precision, bool for boolean, which takes value of true or false, and char for character. To define a variable with any built-in date type, we need to specify the type first. It is followed by the variable name. Then we can, and most of the time we should, initialize the variable with some values. This part is optional, but as I said, it is highly recommended to do so. When we define a float variable and try to initialize the variable with a decimal value, we need to note that the small f at the end of the decimal value is needed. Otherwise, the decimal value will be regarded as a double instead. It is also possible to define multiple variables in a single line, as long as these variables are of the same type. In line 11, we define two doubles, s and v, where s is initialized with value 5 and v is not initialized. And we can see later, when we print out the value of v, it has some rubbish values. The compiler knows how to handle built-in types straight away, but it needs to learn how to handle user-defined types or classes by reading the header files. Here is an example. String is an abstract data type defined in standard C++ library for manipulation with the character arrays. To define a string variable, we need to include the string library first, and then it is possible to define and initialize a string variable as if it is a built-in type. Note that most classes defined in standard C++ library is under the namespace std, so we need to remember to put std in front. Quite similarly, to enable input and output in C++, we need to include the iostream library. This library defines a variable called cout. It accepts different date types for standard output. This cout object receives a series of arguments via the insertion operator. So each one of these items are an argument. What cout does is to print out these arguments one by one, from left to right to the end. Here we need to explain two things. The first one is \n. We see it for several times. It is an escape sequence. What it does is to generate a new line. The second one is endo. We normally put it at the end of the paragraph of cout. So what it does is it tries to output the whole line and then generate a new line at the end. Let's see what the output will look like. But first we need to comment out the remaining part of the program by type /* and start slash, and then we click on compile and run. This is our output. We notice that v has some random values. This is expected because we defined a variable v without initialization. Hence, it has some rubbish values when we try to print out its value. We also notice that flag equal to 1. So flag is a Boolean variable, and it has the value of true. This is also expected because there are lots of existing code which use integer as a flag. So what compiler does is to evaluate non-zero values, including 1 to true, and evaluate 0 to false. It is quite interesting to see that the character arrays and other variables with different built-in types has print out with correct values. It works because the insertion operator is overloaded with a lot of different meanings when used with cout. Up to now, all these variables has their values from initialization when we define them. It is possible for them to get their values from the terminals via the cin object and the extraction operator. Let's uncomment this part. Compile and run. The output is the same as before, and the terminal is waiting for us to input the values for S and V. Let's input 10 and 15. Press enter. And we can see now both S and V change their values. This is their original values. This is their new values. We got their new values from the terminals correctly. That's all for the video today. Thanks for watching, and see you in the next one.